We are going to extend the topic of reversible reactions and talk about the concept of equilibrium. Now, what does equilibrium mean to you when you hear it? Does it mean like something is equal, it's balanced, it's fair? That is kind of like what we're going to talk about in chemistry, except a little bit differently. All right? Now, we talked about reactions being irreversible in the last video lessons. And most of the reactions we studied are irreversible, but when you put them in a closed system, all the reactions will be theoretically reversible, and that is true. And reversible reactions are noted by this forward and backward arrow symbol, right? So it's going in forwards and backwards. So let us use this as an example or an illustration of what is happening during a reversible reaction, all right? So you have the pink and purple reactants, and when you dump it into the closed vessel, it's going to start moving around in random motion and random direction. So it's going anywhere in random motion and random direction, all right, at random speeds. And the purple reactants would knock with other purple reactants, would knock pink reactants, would knock the reaction vessel, and it's just going on in this chaotic motion. However, in some instances, when the pink reactants collide with the purple reactants with enough energy, it will overcome the minimum activation energy barrier, and form products, which is drawn as blue and orange. Right? So you're going to get lots of reactants going around the closed vessel, colliding, and you're going to start making products. So blue and orange products are starting to get formed. And after a while, lots of products are formed, right? You still get reactants, but something is going to happen. The products have nowhere to go. It's a closed system. Remember that. So what's the product doing? Well, it's going in the products out and the reactants that's left over. It's going in very crazy random directions. And the products, like the blue product, is colliding with other blue products, colliding with the orange products, colliding with the reactants, the pink and purple reactants, colliding with the reaction vessel. It's colliding. And when the blue products collide with the orange product with enough energy to overcome the minimum activation energy barrier again, reactants are going to form. So, in this closed system, what you're going to have is that reactants are colliding to form products, products colliding to form reactants. And they are going, the rate of the products being made and the rate of the reactants being reformed are going to compete with each other up until a certain point where the rate of the products made is the same as the rate of the reactants being reformed. And when the rate of forward rate is equal to the backward rate, that is when you achieve an equilibrium. All right? When the forward rate is equal to the backward rate. Now, it's important to know that you talk about the rate being forward and the rate backwards is equal, because this equilibrium does not mean that you have the same amount of products and reactants. It does not mean that. It does not mean that you have the same amount of reactants and products. It does not mean you have the same amount of concentration of reactants and the concentration of products. It does not mean that you have 5 reactants and 5 products. The equilibrium state could be like you have 2 products and 8 reactants, or you could have like 6 products and 4 reactants. What is the equilibrium state? the point of equilibrium? We don't know. It all depends on the condition of the reaction. So, when we change the conditions of the reactions, something is going to happen. You're either going to get more forward reactions or you're going to get more backward reactions when you change the condition of the reaction. But when you give it enough time, a new equilibrium point will be achieved when you again get the same amount of forward and backward reactions at with different concentrations or amounts of products and reactants. It does not really matter. All right. So what are the conditions of these reactions? Well, the conditions will be the temperature of the reaction, and the pressure. These are in the volume, right? But for us, once we understand the concept of equilibrium, what makes it beautiful is that we are now able to, once we know what are the conditions to make the products and all the reactants, we can manipulate these conditions. In addition, manipulate the concentration of the reaction, and we are able to get more products, or we can continue to retrieve back more reactants. Now, it's kind of sketchy right now what I'm trying to say, but I'm trying to make a point that when you change the condition, you will change the equilibrium, right? Let's say you want more products, you can change the condition to get more products, and you can retrieve those products. Or if you want to make more reactants, right, you can change the conditions in another way, get more reactants, and then you take those reactants away or retrieve it. All right? So in the next video lesson, we're going to talk about how changing these conditions will change the rate, the equilibrium in terms of more forward reactions or more backward reactions within the reversible reaction conditions.